All right, now we're going to talk about the basics of electricity. So, what is electricity? Electricity is the collection or flow of electrons in the form of what we call an electric charge. And it's very important that we realize it is either the collection or the flow of electrons. We've talked about in the past flowing electrons being electricity, but electricity can also be a collection of charges, such as you see here the plasma collects right there. It can be the collection of charges, and it can be the flow of charges. Here we go, collecting charges in her hair. All right, so a little review very quickly. Atoms, obviously, protons, neutrons, electrons. The protons are positive, the electrons are negative, and you get that attraction between the positively charged protons and the negatively charged electrons, keeping the atom together, essentially. The electrons, they're on the outer edges. If you collect electrons on something, you're going to gain a negative charge. And the place where those electrons came from, the thing that lost electrons, that's going to be positively charged because it has now more positive protons than negative electrons. So the world, everywhere, there's electric charges everywhere because lots of times, everywhere, electrons are moving around from place to place, causing these charges to occur. All right, so the basics. The law of electric charges. Opposites attract, and like charges repel. So there we go. Opposites attract, like charges repel. So if you have two charges that are opposites, they're going to be attracted to each other. If you have two charges that are the same, then they will push each other away. Now, electrical force is different than an electrical field. The force is the push or pull that comes from those attractions or repulsions that we just spoke about. Here you can see you've got a positive and a negative charge. You can see the force that is attracting them. You can see that force right here that is between them. That is a attractive force, a force of attraction. And that force takes place within the electric field. And that electric field is the area near the charge that you can actually feel, or that push or pull can affect something else. So here, this area where you see these lines, we call those field lines, right? Because it's the electrical field. Okay, we call these field lines, and where these field lines are, that is where the force can cause attraction or repulsion within that field. So the force, electronic force, is actually a push or a pull. An attraction, which would be a pull, or a repulsion, which is a push. This goes back to our definition of forces that we have spoken about before. The force itself is the push or the pull. It's the attraction or the repulsion. The field, once again, is this area around the charge that the force operates. So the difference between a force and a field. All right, so let's talk about moving electricity. I said it's either the collection or the movement of electricity. We're going to first talk about the movement of electricity. All right, we call this electric current. The flow or movement of electrons from one place to another is electric current. We measure electric current in amperes. We usually refer to them as amps. So we measure the current itself in amps. And once again, since it is moving, obviously, it is a source or a kind of kinetic energy. Now we talk about two types of current: direct current, or DC, where the electrons flow in only one direction. We find direct current in our batteries. The current flows from the positive to the negative, That's why you must have them put in whatever you're using appropriately, because if not, then the current will not flow correctly and your device will not work. So we're talking direct current. The electric current always flows in the same direction, always flows in one direction. Direct current. It goes directly there. Very simple to remember. And the other kind, we have alternating current. I think we all know what the word alternate means. It means to change between two different things or multiple different things. Alternating current is current that can flow in multiple directions along the wire. We have this in our homes, in buildings, things. If you plug something into something, it is generally going to be that alternating current, the plugs that we think of when we plug in our hair dryers, our computers, our chargers, our printers, all those things are alternating current. All right, this is simple. A conductor is a material in which charges move very easily. Things like metals, we spoke about in the matter unit. Metals having that specific metallic bond with the electrons being very loosely kind of in a cloud around the protons. Obviously, since they're very loosely connected, they can flow very easily. So conductors, that's a material in which charges flow easily. And an insulator obviously would be the opposite. Charges do not flow easily. Here we have a traditional wire that we might think of made of a metal, copper. You have that as your conductor, and then it is surrounded by an insulator to obviously keep those charges, those electrical charges, that flow where we want it. So it can't flow out of here, it stays in here on the metal wires where we want it. So this is a combination. We have our conductor here and our insulator keeping our charges where we want them because they cannot flow easily through that insulator. Some good examples: conductors, metal, water that we use that has a lot of, atoms in it, some different kinds of things, not just pure water. Pure H2O is not a conductor, but very rarely do we find pure H2O. The waters we usually come across have multiple things dissolved in them, causing them to be good conductors. Insulators, styrofoam, rubber, plastic, paper, glass is often used as an insulator. These things keep electrical charges from flowing easily. It's a very similar concept to conductors and insulators with heat. So, how do we control where our current goes? Well, we use circuits. A circuit is a specific path that we want that electric current to flow through. We want to show those electrons where to flow, and so we create a circuit. And to do this, we use wires. We want our electrons to flow along our wires. So there are two different kinds of circuits that we are going to talk about and work with. A series circuit is one in which all the components are lined up along a singular path. If the circuit is broken in any one spot, all of the parts of that circuit turn off. So there's only one path for the electrons to flow along. Therefore, if that path is ever broken, then it all turns off. This is an example of a series circuit. Here we have our power source, which we also call the cell. And then here is our circuit, right? Here's our wire for our path. These are our light bulbs. We call these the load, where the work is done. Should be familiar. And you see they are all in a straight line, right? Only one path for these electrons to flow. There's also a parallel circuit, in which case there are several branching paths. Branches out. There's multiple paths for the electrons to flow. If that circuit is broken, then only the branch that is broken has a problem. And this is a good example right here. You can clearly see with all these different branches, there are multiple paths for these electrons to take. So they can go here or here or here or here, and they're going along there, right? And if this circuit is broken right here, then all these will still work. This one is the only one that has a problem. So you have series which is one singular path, and if it's broken anywhere, it all shuts down. And then you have parallel, multiple paths, and if any one path is broken, then the rest continue to work. Okay, so that circuit, that's that closed path through which electric charges flow. We want our circuit to be closed. A closed circuit allows the flow of those charges. A closed circuit allows for the flow of charges. You do not want to open your circuit. An open circuit does not allow for the charges to flow. Once again, the cell. It is the stored energy that we can transfer into our circuit, right? The cell is our source of energy, right? We're using chemical energy to push the current through the circuit. The load is whatever is being powered by our circuit, right? The load is what the work is done on, thereby, this is nothing new. Here our light bulb is clearly our load. We have our cell, we have our path, and we have our load. A switch is what we use to open and close circuits. Any on-off switch on your electronics that opens or closes your circuit. When something is turned off, the circuit is open because we break the path for our electrons to flow on, and they cannot flow along that broken path. So when we open our circuit, we turn things off. And when we close our circuit, we turn things on. Because we close it, we make it a complete circuit again, and thereby the electrons can flow. Okay, so fuses, these are awesome. You'll find these in multiple circuits. You'll find them in your car. You'll find them in your home. And this is a very good picture of a burnt fuse. Okay, a fuse is going to contain this thin strip of metal, right? And when the strip of metal is complete, then that is going to be your closed circuit. But if the current gets too high and there's too much energy flowing through there, then that thin strip of metal will melt, as it is done here, and you see our circuit is open. So our electrons, they cannot flow, so it turns off our power supply. So we do not get those electrons flowing anymore because the circuit here, as you can see, is open. Open circuits mean no flow. And a circuit breaker is a switch that's going to automatically open when the current is too high. You also have one of these in your home. Everybody has one. And when sometimes you plug too many things into a certain circuit, the energy level, the flow, the current gets far too high, and it forces the switch to open that circuit, causing the flow to stop. It's a very similar concept to a fuse, only this is obviously reusable because it's just going to open the circuit. You can close that circuit with the switch, whereas a fuse is not reusable. All right, I hope you have the basics of electricity understood, and we will work with this soon.